Hi grade 12s and welcome to this video. In this video, I just want to go over 4 questions in the November 2023 exam. Okay, so if you go on my channel and you go to the videos, you'll see that in the November 2023 exam, this exam over here, you'll notice that there were some mistakes in 4.5, 4.6, 4.7, and 5.5. Okay, so this video is just a short video to correct those errors. Now, I hope it was still helpful for you because the errors were actually just typing errors, or like a mistake that I made with a number. For example, there was one where I forgot to put a negative in front of a number and then that changed the final answer. But I hope you were still able to use it to practice. So I'm releasing this video now just so that you have the corrections on that and you have something to look back on when you're practicing for your 2024 exam. Okay, so with question 4, we're just going to start from 4.5 because that's really all we need to be able to answer that. So remember that they told you sketch below is the graph of f of x, and then you can see it's this exponential function, okay, and it has -4 there. So you know that the horizontal asymptote is y equals -4. Okay, we already went through all of that in that video. But then what we have is that the domain is going from -2 to +4. Well, not exactly at +4, but right before +4. So it's not necessarily equal to +4, okay, but it is equal to -2. So with that, the question here is write down the equation of g if it's given that g of x is equal to f of x plus 4. So if we know that g of x is found by saying f of x plus 4, then to find g of x, all we're going to do is take the function of f of x, which we know is 2 to the power of x minus 4, and then we just say plus 4, right? And so g of x is equal to 2 to the power of x. Now, I know I already did this in that part, but I want to make sure that I include the domain as well, because the original function f was restricted, okay? It can only go from -2, exactly -2, and then to 4, but just behind 4, not exactly at 4. Okay, so just like before 4. Okay, so it's not really equal to 4. So we have to also put a domain here as well. So this is the way you can see it. Because the graph was already restricted on the domain, okay, the other graphs that come from this will also be restricted to this domain as well. So the domain here is where x is an element of, and it's the same domain that we have. It's going from -2 all the way to less than 4. Okay, now there is a reason I'm doing this, because the next question is going to have a lot to do with this question, and we're going to really have to look at that domain. Now, the next question, 4.6, said, write down the domain of g, -1. Okay, so the inverse of g. So when we're writing the inverse of g, again, like I've explained in the original video, we're going to have to think about what the original function looked like, which is the function of g of x, okay? Because remember, the graph of f, this graph that is represented here, it was translated, okay? They shifted it 4 units up. And because of that, it became this graph of g. So they are specifically asking us for the domain of the inverse of g, not the inverse of f. So we'll have to use the graph of g, okay? So this is the original function, and then we need to see what exactly the inverse is going to be. So let's figure out how we're going to find this. They say write down the domain of the inverse. So we need to find the domain of this one, right? Now, the only way you can find the domain of this, remember the relationship between the original function and the inverse. The range of the original becomes the domain of the inverse, and the domain of the original becomes the range of the inverse. So you see that in order to find the domain of the inverse, we need to find the range of the original. Okay, now remember, the domain of the original function is this. So how do we find its range? Because it's only going to start at -2 and then end at 4 for the x values, then it means its y values are also going to be restricted because of that. Okay, so remember that the graph of g was shifted, it was transformed, it was translated 4 units up. So it would have looked like this graph, just doing this as well. But because it was translated 4 units upwards, it now moves, it shifts 4 units upwards and then lands here. And you can actually find out where exactly it lands because you know that the horizontal asymptote of the graph of f was y equals -4. That's why we have that -4 over here. If this graph shifts up, that y value is going to move up by 4 units. And now the new horizontal asymptote is y equals 0. So it's just above 0 like that. That is the graph of G. Now, this graph of G is also restricted to this domain as well. Remember what we're trying to find, okay? The domain of the inverse. And we know that the domain of the inverse is found by finding the range of the original. So we'll find this one first. Okay, let's find the range of the original. So if our graph is G, right? And this is the graph of G here. The range is going to be found by taking these domain values, the x values, and substituting it into the graph of G. So for -2, we'll substitute -2 as an x value so that we can find out what exactly its y value is. Where is it starting? So we can do that. We'll say g of, so we're using the original function, and g of -2, and that's where I made a mistake. I said +2, and then that caused the error there, is equal to, and we're taking our function of g, and our function of g, we know what it looks like already. It's that. So that is 2 to the power of -2, which gives you 1/4. So you see, it starts at 1/4. And where does it end? Okay, so this is the y value. The highest y value you'll get is here, and it is the one that goes with this 4 over here, that restriction, okay? So substitute 4 to get that highest y value on the y-axis. Okay, so substitute 4, we'll say g of 4, and we get is equal to 2 to the power of 4. 2 to the power of 4 is what? 16. So it means that this graph is starting at 1/4, and then it stops at 16 and doesn't go anything beyond that. That is going to be the range. So the range here is y is an element of, now it starts exactly at 1/4, but then it's nothing more than 16. So it's not exactly 16, but it's just less than 16. So it looks like that. Remember, the final question was, you need to write down the domain of g of -1. So because this is a domain, it's going to be exactly the same. The only difference is it's not going to say y, it's going to say x. So x is an element of 1/4 going all the way to 16. And that's going to be our domain. So that is our domain of the inverse of g. Because remember, the graph of g was already translated. It was shifted up by 4 units. Okay, then we move on to 4.7. And then the last question, 4.7, I just want to redo this so I can include something in it. The question was, write down the equation of the inverse of g in the form of y equals. So we already have the original function of g. It's 2 to the power of x. So to find the inverse, we rewrite it first of all as y equals 2 to the power of x. Then swap x and y. So x equals 2 to the power of y. Then make y the subject. So y equals, and to make an exponent the subject, you're going to have to use log. So we'll say log of our base, and our base is whatever was carrying the exponent, which is 2. And then we have what the exponential expression was equal to, which is the x. Okay, so log x with the base of 2. And that is going to be the equation, right? But I wanted to just make sure that I include this as well. Because they said in the form of y is equal to, I wrote that, but let us also write down its domain. Okay, that is important as well. So where x is an element of, what would be the domain of the inverse of g? So we already have this whole relationship thing down. The domain would be this again. Do you see that we already have it down? Because we had to find the range of that in order to find the domain. So I'll just write that. So I'm telling them that where x goes from 1/4 and is nothing more than, or is less than 16. So there we go. And that is our answer there. And then we'll move on to the last question that I'm going to just look at, which is 5.5. Okay, so in question 5, we're only going to deal with 5.5. So just remember, they gave us the graph of f, which is a parabola, a concave down parabola, and they gave us the graph of g, which is a hyperbola. Okay, so we don't actually need any points on the hyperbola. We have enough here, so we can actually work with this. So here's the thing that you need to remember. This is a hyperbola, but do you see that it doesn't have a q value? Okay, a hyperbola is always in the form of y equals a over x minus p plus q. Okay, it has a p value, which is 0, and its q value technically is 0. That's why there's nothing showing there. Okay, so what we need to take note of there is that, first of all, its vertical asymptote is x equals 0, and its horizontal asymptote is y equals 0. So let's keep that in mind. Okay. So the question for 5.5 is, for which values of f will f of x multiplied by g of x be less than or equal to 0? So let's think about it like this. You're going to have to think about the y values of f and g. When you multiply them, they need to give you something negative or equal to 0. That's what less than or equal to 0 means. So f, for example, can be positive, and then if g is negative, then they'll give us something that is negative. Of course, either one of them can also be equal to 0 to give us something equal to 0. So we should just keep that in mind. The second scenario is where f can be negative and g can be positive, and then they'll give you a negative. They can also either be 0 as well, or even both of them be 0, and we can also consider that as well. So here is how we're going to look for that. We're looking at the graph of f and g and looking for the places where they are negative and positive, or positive and negative, okay, like that. So again, you can use a vertical line, you can use your ruler and go through this. You see here for these x values here, look at what the graph has. Here, it has a negative y value. This graph, negative y value for that same x value. So it will not work there. If you keep moving to the right, it still has a negative y value for the graph of g, as you can see there, and a negative y value for the graph of f. As we keep moving, it keeps being negative and negative until we get to this point. Do you see that at -3, the parabola has a y value of 0, and then the graph of g has a negative y value, whatever that number is. So we can see that it works from -3. Let's keep going. Does it work here? Here, it is positive. It has a positive y value, and for that same x value, it has a negative y value. So that works out. That's positive and negative. Okay, which is what we're looking for, positive and negative. So we're going to take that from there, keep moving. Do you see that it keeps working? Positive and negative. Keep moving, positive and negative. But now we need to take note of something that happens with the hyperbola. Hyperbola starts to decrease and decrease. And then what happens at the x value of 0? It will never touch 0, okay? So keep that in mind. Yes, this would have kept working because you see that this one has positive y values, that one has negative y values, great. But this one will never pass 0. So that means that it's working from here, and then it keeps working until this point over here. Let's actually just put that down. Keeps working till here, okay? Because after that, the parabola is no longer negative. After the 0, it's positive. It's coming from being very close to this x value of 0. So it shoots up, goes closer and closer to the y-axis. Okay, so it works in between here for these parts of the graph. Okay, and we're going to write that down. That is where x is going to be. It's really just between, well, I don't know why I put it there. It's not between these two here. It starts at -3, okay? So it starts where x is greater than or equal to -3, okay? Remember, it's equal to -3 because at -3, the graph of f has a y value of 0. So y value of 0 multiplied by this y value of a negative something, that gives you 0, which is one of the requirements here. It must be less than or equal to 0. So less than or equal to -3. But then remember what happens at 0. There's an asymptote here. So it's not going to go beyond 0. It's not even going to touch 0. So, or less than 0, not equal to 0. Or, and then the last point here was this. Here's how we can find the other parts of this. Do you see that if you keep moving with this vertical line, do you see that over here, you see they're both positive. because this graph is really close to the y-axis. That's what's actually happening. And then they're both positive still, both positive, both positive. Keep being both positive until we get to this point over here, the x-intercept of the graph of f. At this point, the graph of f has a y value of 0, and the graph of g has a positive y value, as you can see over there. Okay, so it works at 5. And then when you go beyond 5, look at what happens. You have a positive y value for g and a negative y value for f. Keeps on being positive y value for g, negative y value for f, which is what we're looking for as well, positive and negative. So it means that it starts working here at 5 and then everything else for that same x value. So everything here. Okay, so that means x is, these are values that are greater or equal to 5, greater than or equal to 5. So that will be the answer there. Okay, my error here was I forgot to include this equal to. So that's just going to help me know that I just need to be a little more careful with these and make sure not to make errors. Guys, also do that in exams. I know it's not very easy to do that when you are writing for a whole 3 hours. But that is why you need to make sure you have studied ahead of time, and the night before the exam, don't stay up watching past the exam paper videos. It actually doesn't help like that. You have to rest. If your mind is rested, you will think way better than if you got only 3 hours of sleep. Okay? So that is it for this video. I wish you guys all the best for your November 2024 exam, and I will see you guys in the future videos. Bye for now.